Okay, so let us continue our discussion. A while ago, I have mentioned the forced convection and the free convection, right? And that is actually one of the, I mean, two of the uh, sub modes of the convection heat transfer. Actually, we have three modes of the convection heat transfer. Okay, so the convection heat transfer are classified into three sub-modes. The first one nga is the what we call the forced convection. Okay, so technically when we say forced convection, it is, when we have a flow or the motion um, is caused by the external means, okay, such as what are those external means, um, such as fan, like what I have said, the pumps, blowers, or either the atmospheric winds. Okay, so let me write it. When the flow is caused by external means. Okay, okay, so the examples of this forced convection is that, say we have a forced air coolers. What else? The evaporators is also an example of this forced convection. The condensers and the heat exchangers. Yeah, those are examples of forced convection because the motion of the fluid there is caused by external means, by having a fan, a pump, or maybe an atmospheric wind. Okay, so the next one is the free convection or the natural convection. I have also mentioned it earlier that when the fluid motion is, self-excited by the buoyancy effect due to the temperature gradient, the mode there is called the free or natural convection, right? It is when the flow is induced by the buoyancy forces. Um, uh, what happened there is usually the density differences caused by the temperature variation of the fluid, right? So examples are the evaporators and condensers of the household refrigerator. Okay, so another, the radiator and convectors for space heating, heat loss and heat gain of connecting ducts, and so on. Okay, basta always remember that if our mode is the flow is caused naturally by buoyancy forces due to the temperature difference, there is a natural flow of your fluid, then it is a free or natural convection. But when the flow of your fluid is caused by external means, such as by fans, pumps, and so on, then we have a forced convection. Okay, okay, okay. And the additional or the third sub modes of convection heat transfer is the what we call the change of phase. Change of phase. Okay, So literally, the example of this phenomenon is when we have, when boiling or condensation takes place. Okay, so we have the change of phase. Ayun. So once again, always remember these three: the forced convection, the free or natural convection, and the change of phase. So for illustration, let's view this. Say forced convection, say this is your solid material, say this is your plate. Okay, and we have our fluid that is in motion. Say this is our air. Okay. Okay. So we have a convection heat transfer between these two. Between these two, the plate and the moving air. The submodes, the submode of this convection heat transfer is forced convection if this moving air is caused by some external means, and say we have here a pan. Okay, a pan causing your air to flow or move. Okay, so while when we have this natural or free convection, say this is your flat surface again, then say there is a buoyancy forces due to uh, the the temperature difference, which are due to the density difference caused by the temperature variation. Then say your, for example, your air goes along this way, going up. Okay, so there is a heat transfer there between your solid surface and the air. Okay, so this one here naman is an example of free or natural convection. Okay, once again, always remember, free or natural convection is induced by buoyancy forces due to the temperature difference, and this one here is the forced convection if the motion of our fluid is caused by these external means. Okay, the convection heat transfer relations are complex in nature because of the dependence of the convection on the flow conditions. So we have different flow conditions as well as the fluid and thermal properties, such as we have the dynamic viscosity, so that is one. We have also the thermal conductivity. We have also the density, the specific heat, the fluid velocity, what else? The surface geometry, and surface roughness. Okay, that's why the convection heat transfer the relations excuse me, that's why the convection heat transfer relations are complex because of this dependence of convection on flow conditions such as this. okay, such as the fluid, and thermal properties such as these properties, okay. But although convection is said to be complex, the rate of convection heat transfer, right? The rate of convection heat transfer is proportional to the temperature difference and is usually expressed simply by this equation, the H Ts over the surface minus the temperature of the fluid, assuming that the temperature of the surface, if we have this kind of equation, simply means that the temperature of the surface is greater than the temperature of the fluid, right? Okay, okay, so although once again the convection is said to be complex, but the rate is the rate of convection heat transfer is proportional to the temperature difference and only expressed through this expression. Through this equation, right? Okay, where um, the this symbol here, the the rate of convection heat transfer or the heat flux. This is our heat flux term, heat flux if we have in watts per unit area. Okay, so we have this heat flux watts per unit area. Okay, and our H is of course the uh, convection heat transfer coefficient, convection heat transfer coefficient in the unit is in watts square meter per degree Celsius or per temperature. Then our Ts, of course, like what I have said, is the surface temperature, the temperature of your solid surface in degree Celsius, and the uh, infinity is the temperature of the fluid that is sufficiently far from the surface. So temp of the fluid, usually it is air or maybe a water and whatever fluid it is. Okay, it is also in unit temperature. Okay, though we say last time that the convection, since it is the relations are very complex uh, due to these properties, but when we see this using this expression, then I mean it is just simple expression, right? But the main challenge here kasi is the how to find your or how to define your convection heat transfer problem, is how to find the heat transfer coefficient. Okay, so that is the main challenge here in um, convection heat transfer, because you cannot have this um, easily. You need to consider all these properties and conditions to define this H alone. So that is the main challenge here in convection heat transfer. We need to find this value of this convection heat transfer coefficient. Okay, so on the next video we will gonna tackle deeply regarding this convection heat transfer coefficient. Okay, so see you.